Alright, so we're going to work on Taylor's theorem. I want us to construct a polynomial that fits this form. P of x equals to a0 plus a1x all the way to a4x to the fourth. And I'm going to have some conditions. I want them to satisfy the given. P of 0 is 1. P prime of 0 is 2. P double prime of 0 is 3. P triple prime of 0 is 4. And the fourth derivative of p at 0 is 5. So I want to use these givens to identify all my constants in the front. All of these a's I want us to figure out. So let's first just start off. Well, since p of 0 is 1, then that must mean a sub 0 is equal to 1. That one's kind of easy. So I've used this first given. Well, how do we use p prime of 0 equals to 2? Well, we need to find what p prime of x is. So p prime of x is going to be a sub 1 plus 2 a sub 2x plus 3 a sub 3x squared plus 4 a sub 4x to the third. So we merely take the derivative of all our terms. And since p prime of 0 equals 2, then that means I'm going to plug in x equals to 0. Again, this one's kind of nice. Well, a sub 1 equals to 2. We do need to find the second derivative to double check. Well, we're going to have 2 a sub 2 plus 6 a sub 3x plus 12 a sub 4x squared. So right off the bat, I already know that it's going to be a little bit different this time because p double prime at 0 is equal to 3. So that means a sub 2 equals to 3 over 2. And now I can calculate the third derivative, and that's going to be 6 a sub 3 plus 24 a sub 4x. And the third derivative at 0 equals to 4. So that means a sub 3 equals to 4 over 6. And now I need to use the last one, the fourth derivative. I'm going to write it over here on the left-hand side. The fourth derivative of p is 24a sub 4. So the fourth derivative of p at 0 is equal to 5. 5 equals 24a sub 4. So a sub 4 equals 5 over 24. Now these are all my constants that I've highlighted here in pink. So that means p of x is going to equal 1 plus 2x plus 3 over 2 x squared plus 4 over 6x cubed plus 5 over 24 x to the fourth. Can you guys see why I chose to keep the fraction a sub 3 for a sub 3 as 4 over 6? That way I can see the numbers 1, 2, 3, 4, 5 in my numerator, which happens to match up with these coefficients that I wanted in the beginning, 1, 2, 3, 4, 5. Now, I want you guys to just kind of take a look and see where these numbers 2, 6, and 24 might have come from. These fractions as over 1 over here, do you notice anything? That's actually 0 factorial, 1 factorial, 2 factorial, 3 factorial, and 4 factorial. I want us to now construct another polynomial, p of x, to match up similarly to this one that we have above. So a sub 0 plus a1x plus a2x squared plus a3x to the third plus a sub 4x to the fourth. But this time, I want it to approximate this function, ln of 1 plus x, at x equals to 0. Well, I'm going to call this my function, f of x. So I need to find out what f of 0 is. Well, that's going to be easy. We plug in 0. So ln of 1 plus x when x equals to 0 is going to equal ln of 1, which is 0. And now I'm going to find what f prime of 0. Now pay attention to the notation I'm using. I'm going to find the derivative, and then I'm going to use this conditional bar, just like we use in our graphing calculators, to say when x equals to 0, so this equals to 1. So now the derivative here is negative 1 over 1 plus x, quantity squared. And when x equals to 0, this is negative 1. And the third derivative of f is going to be 2 over 1 plus x quantity cubed. And when x equals to 0, this equals to 2. And I need to do one more. The fourth derivative of f at 0, it's going to be negative 6 over 1 plus x quantity cubed at 0 is equal to negative 6. So these are the numbers that I need, my coefficients. Following sort of the pattern that we had before, can you tell what our polynomial is going to be? Can you match it up to what's going to be here? So I'm going to go ahead and say that p sub 4 of x is going to be 0 plus 1x minus 1x squared over 2 factorial plus 2x cubed over 3 factorial minus 6x to the 4th over 4 factorial. Here's how it's going to be pretty easy to remember what these factorials are on the bottom. Notice that 3 factorial matches up with the 3 up here. 4 factorial matches up with the 4. And same with the 2 and the 2 factorial. So this is going to lead to what we call the general form for our Taylor series, centered about x equals to 0. So we say that f of x equals to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial, and then so on, so that you have the nth derivative of f at 0 times x to the n over n factorial, and then this also goes on forever. Now, keeping in mind here that this is really over 1 factorial and over 0 factorial with an extra x to the 0 here. Alright, so we're going to do 2 more. We are going to construct a 7th order Taylor polynomial for sine x at x equals to 0. Okay, 7th order polynomial simply means highest power is a 7. Okay, so since our function is sine x, what we need to do now is figure out what this function value is at x equals to 0. So sine of 0 is 0. Then we need to find the function value of its derivative. So cosine of 0 is 1. Second derivative is now negative sine x, so that's back to 0. Third derivative is negative cosine x, and that's negative 1. And then when we do the fourth derivative, hopefully you'll know that it just loops back around, so this repeats. And so therefore we can say that sine x equals to 0 plus 1 times x plus 0 times x squared over 2 factorial minus 1 x cubed over 3 factorial, and then it loops back around, so plus 0 x to the 4th over 4 factorial. Here I actually have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. This is my approximation from the 7th order polynomial representing sine x. And if I wanted to write this out, as a general form, I could say that sine x can be written with the polynomial. This is going to be an alternating series. So this is going to be negative 1 to the n, x to the 2n plus 1, and then 2n plus 1 factorial. And the IOC for sine functions are all real numbers, because any value of x is going to make this work. And there's our Taylor polynomial for sine of x. So now let's try cosine of x. This is our last one. Let's find the 6th order Taylor polynomial for cosine x. So that means I need to find the first 6 derivatives. So f of 0 for cosine x is going to be 1. F prime is negative sine, which is 0. F double prime is negative cosine, which is negative 1. F triple prime is positive sine, and I get 0. What you'll notice is all of the odd-numbered derivatives are 0, so that I can say that my 6th order Taylor polynomial is going to start out with a 1 plus, then this is 0x. So now I have negative 1 x to the second. So it's going to be 1 minus x squared over 2 factorial. And the third one is 0. Then the fourth one will be x to the fourth over 4 factorial minus x to the 6th over 6th factorial. This is going to be approximately cosine of x. And if I wanted to write the whole thing so that the series goes on forever, this is again an alternating series, so I have negative 1 to the n power. This is going to be x to the 2n, and then I have 2n in parentheses factorial. Make sure you notice that 2n factorial without the parentheses is not the same as 2n factorial with the parentheses. Here is the power series for cosine, as well as the power series for sine. And also the IOC here is negative infinity to infinity.